Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the grouping of the cells, and here we are going to see series combination, parallel combination, mixed combinations and questions based upon that. But the question arises, what is the cell? So remember that a cell always converts chemical energy into electrical energy. But depending upon our requirement, number of times we have to connect the cells to make the battery. Okay, so all these things we are going to learn how to make the battery depending upon the external resistance situation. Okay students, so let's start the video and let's learn all these important things. Okay, so you can see grouping of the cells. So students, here you can see very well here, cells are grouped in series, parallel or mixed combination based upon external resistance capital R to make battery. Okay, so external resistance will decide which type of combination we have to use it. Okay, great. Now students, first one we are going to see the series combination. So here please, let two cells of EMF E1 comma E2 and internal resistance R1 comma R2 are connected in a series as shown in diagram. I will draw the diagram. Okay, their equivalent EMF ES and internal resistance RS can be calculated as. So students, here kindly see here I have taken here the one cell. No? This is the internal resistance of the cell. After that again I have taken here one cell, and that is the internal resistance. This is the terminal A and B. Okay, and here you can see very well, this is the E1, R1, this is E2 and this is the R2. Okay, and by default what will happen that here, remember that here by default always discharging situation will draw here, and this is the external resistance. Okay, so what will happen that here, depending upon the polarity, you know very well, this is the plus minus, current will flow in this direction. Okay, like this current will enter. Okay, so students, here if I will write here the polarities. Okay, so current is flowing in this direction, means this is plus, this is minus. Similarly this is plus, this is minus. That means voltage drop across the resistors. Now students, if I draw here the equivalent diagram. Which diagram? Equivalent diagram. So remember that here I will take here one cell, and here let's take here this cell is ES and RS. Okay, and through this we are going to connect here one resistor. Okay, like this, capital R. And you know very well students, this is point A, this is point B. That means a single cell which is going to replace these two cells. First we are learning for the two cells. Even we can extend our discussion for 3, 4, 5 cells also. Okay students, so here what will happen that here, first we are going to talk about here this cell. Okay, and we are going to write the potential difference across the cell. That means terminal potential difference. So from the KVL we can write here this VA, start with the VA, and the second polarity minus E1. After that we can write here plus IR1, second I'm taking here. After it, see here minus E2 plus IR2 is equal to where I reached at point B. Okay, so students, when you will simplify this, it will come here. See here VA minus VB will come here, E1 plus E2. Now I have taken that side here, minus IR1 plus R2. Okay, minus IR1 plus R2, and this one I will make here students, I have make here, this is equation 1. Okay, similarly what we are going to do, the next one we are going to see. Okay, now we are going to use the KVL in this equivalent circuit diagram. So here what will happen that here, you know very well, this is plus anyhow, this is minus, long line plus, short line minus. Okay, so here what will happen that here, VA minus, you can see very well, minus ES, second polarity always, plus IRS is equal to VB. Now VA minus ES plus IRS equal to VB. So here what we can write here, here we can write VA minus VB is equal to ES minus IRS. Okay, and this is the equation 2. So students, the first equation I have made from the actual circuit diagram, second equation I have made from the equivalent circuit diagram. Now I will compare both equations right side. Okay, so you can see very well here, you can see very well here, you can see here this is ES, this is E1 plus E2, this is RS, this is what, R1 plus R2, is it? So that we are going to write here in a next one. Okay, so what will happen that here, students, if I will write here, see here, the first thing I can write here, this ES equivalent is given by E1 plus E2. Okay, ES is the E1 plus E2. Similarly, RS is given by what? R1 plus R2. Is it? And nothing is mentioned, nothing is given. Always we will draw here in a supporting polarity. Okay, supporting polarity means what here? Due to this E1, current this side, due to this E2 also, current in same direction, that is the supporting polarity. Okay, great. Now students, similarly, if I write for the N cells, in supporting polarity, that means what we can write here, see, ES equal to E1 plus E2 plus E3, okay, dot plus En. Okay, similarly, if I write here the resistance, it will become here Rs equal to R1 plus R2 plus R3 dot Rn. Okay, and remember that here, this series combination, we will use it whenever we need the high EMF. Okay, that time we'll use here the series combination. Okay, remember that here, high EMF, high resultant EMF. Now let's see some important points. So first point is what's here? If cells of EMF E1, E2 are connected in a supporting polarity and E3 in a opposite polarity, then their equivalent is given by. Okay, so here what will happen that here, remember that, see how I'm doing here, see, this is the point A, this is the E1 and this is the E2. Now this is the supporting polarity. Why? Because due to E1 also, let's take this is the E1 R1, due to E1 current left side, even due to E2 also current which side? Left side. Okay, so this is the supporting polarity. And what will happen at here? This E3 in which polarity? Opposite polarity, like this. No? So this is the E3 and here we will draw here the resistance R3 and this is point B. Okay, so how can we tell here, students, supporting polarity, opposing polarity? Here this plus minus, here plus minus, but here minus and here plus. Okay, so students, with the same basic, what we can write here? Remember that here, this equivalent will become here E1 plus E2 minus E3. And resistance is the bipolar device, so no change, R1 plus R2 plus R3. Okay, so this thing you have to remember that here, by default supporting polarity, but if in the question they told, then we have to see that. Okay, now the other points are that, see here please. Second point, what is the second point here, students? You can see here, see, if n identical cells are connected in series, identical cells means here each and every cell is having EMF E and internal resistance is smaller. Okay, so in this situation, equivalent EMF ES is given by N into E, because E plus E plus E plus E n times, then what it will become? It will become NE. Okay, similarly students, equivalent resistance is given by Rs equal to NR. Okay, Rs equal to NR, remember that here. Next one, what will happen that here, see, current through external resistance I is given by, so remember that here, if I write here, see, this is the situation I'm drawing here. So see here, this is the NE, this is the NR, and here we have connected here one external resistance R, and this is the terminal potential, means terminal points here. Okay, so NE and NR is there. Okay, and through this current will flow. Okay, so see please, this is the current is flowing here. So by using the basic Ohm's law, we can tell what this I is given by NE by NR plus capital R. Okay, total EMF by total resistance, both are connected in a series. Okay, if you want to write the polarity also, this plus this minus, this plus this minus, same current will flow. And I think so the direction I have done wrong. Now this one here, this current, this I will go like this. Is it? Great. Now students, see D, if external resistance capital R is much higher than the total internal resistance of the cell, remember that, then cells should be connected in series to get a maximum current. Okay, and what it is telling that here, remember that here, R should be greater than equivalent, that means NR. R should be much higher, that means R greater than NR. That means, students, if I will write here this R plus NR, now see here please, this R plus NR will become what? R is very high, so we can write here R. Okay, so in this situation what will happen right here, if we see from here, this I max will become here what? N into E, and this NR plus capital R will become what here? R. And in this situation, it will be maximum utilized here. Okay, students, so remember that here we have to use the series combination when the external resistance is the very high compared to the internal resistance. Okay, great, great. Now students, next one here, from here question used to come, see here, if out of n cells in series, m cells are connected in reverse polarity, then their equivalent is given by. Okay, so remember that here in this situation, this equivalent ES is given by n minus 2m into E. Okay, this thing have to remember that here. And let's take for example resistance. Resistance is a bipolar device, so no change and all. And here what will become here? It will become here NR. Okay, and students, here I will take here one example also. Let's take, we have the total number of cells are 100. Okay, and let's take by mistake 5 cells are connected in a reverse polarity. Then even you can comment. Okay, so what will happen that here? This ES will be what? 100 minus 2m, that means 2 into 5, 10 into E, it will become here 90E. Okay, this will be the equivalent EMF. Similarly, resistance, no change, NR, that means here 100, so we can write here 100 R here. Okay, so students, resistance, there is the no change and only EMF will change. Okay, is it? Great. Now students, now we are going to see here the parallel combination. Now series combination we have learned very well. Now what we are going to do? The parallel combination. Important, derivations are very important for this. So see here, parallel combination. Let two cells of EMF E1, E2 and internal resistance R1, R2 are connected in a parallel as shown in diagram. Their equivalent EMF and internal resistance can be calculated as. Okay, so just let me draw here the diagram here. See, by default means supporting polarity. So see E1 and here R1. Similarly here the students is here E2 and here R2. Okay, and this is the anyhow the terminal AB. Okay, and here I will connect here one load I will connect here, external resistance, that means R. Okay, so what will happen that here? Remember that here it will happen, current will flow this side. Let's take this is I1, this will flow here I2, and here current will go I, is it? And here again current will go I. Now, and anyhow, if you want to draw here the equivalent, so equivalent anyhow you know very well, this is the EP, this is here RP, and here we will connect here one resistance here. Okay, this is the equivalent. Now equivalent always used with easy only, is it? So here current I this side and here current I this side. Okay, students, derivations are important. Okay, this derivation important. So we can write here, see, by KCL, that means Kirchhoff's current law. What we can write? Remember that here we can write here I equal to I1 plus I2 here. This is the junction here. Now here we applied the KCL. Okay, great. Now what will happen that here? This is a discharging situation. So you know very well that discharging situation always used to be V equal to E minus IR. Okay, this is the discharging situation, we always use it. Okay, so from here what will be the I we can write here, remember that here E minus V by small r. Now this remember that I equal to E minus V by small r. Which situation? Discharging situation. Okay, great. So now what will be the I? This I will write from here, from the equivalent diagram. So what this will become here, see, EP minus V by RP equal to what is I1? I1 I will write from here. I1 will be what here? Remember that here this potential difference is V only. Okay, see, this is the potential difference V, and here also this is the potential difference, how much here? V. Okay, so we can write here I1 means E1 minus V by R1 plus E2 minus V by R2. Now then let's separate it. So we can write here, see, EP by RP minus V 1 by RP. Okay, is equal to, again you separate here, E1 by R1 plus E2 by R2. Okay, and here what will become here? Can you see here? Minus V, and here we have to just simplify this. So it will become here 1 by R1 plus 1 by R2. Okay, so this equation is ready. Now both the sides we will just do the comparison. What comparison will be happen? Remember that here this and this comparison, and after that coefficient of V and coefficient of V comparison we are going to do. Okay, so what will happen at here? Remember that this will become here, first one here EP by RP will become here, see here, E1 by R1 plus E2 by R2. Okay, and if I write here the coefficient of V means 1 by Rp is equal to 1 by R1 plus 1 by R2. This formula you have to remember that. Okay, after that we can even simplify somewhat. Rp equal to, like, we can write here parallel combination, so R1 R2 by R1 plus R2. This is the thing. Okay, and after that if I will simplify, this is somewhat. So what this will become here, see, this EP is given by Rp. Rp will go right side. So we can write here, see, R1 R2 by R1 plus R2 into, take here the LCM, see, E1 R2 plus E2 R1 by R1 R2. Okay, so what will happen that here, you can see very well, this R1 R2 will cancel out. That means we can write here, this equation will form here. I am writing here, see, E1 R2 plus E2 R1 by R1 plus R2. Okay, this thing you have to remember that. Okay, similarly if I write here for the n cells, see, for n cells in parallel, supporting polarity. Okay, so what this will become here, remember that here, this EP by Rp is equal to E1 by R1 plus E2 by R2 plus E3 by R3 dot 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 plus En by Rn. Okay, similarly if I write for the resistance, means 1 by Rp is equal to, you know very well, 1 by R1 plus 1 by R2 dot 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 plus 1 by Rn. Is it? So this thing we have to remember that, because multiple cells they may give. Okay, so see here, now after that we are going to see here the important points. So see the first points. If n identical cells are connected in parallel, then, okay, so when you will use here this basics, very easy it will come here, see. So for n identical cells, when it will solve here, it will come here EP equal to only E. Okay, just use this basics here. No, EP will come E. Okay, similarly what will happen that here, if I write here the Rp will come here R by N. Rp will come here how much here, R by N. Kindly remember that parallel combination they used to ask, like 5 cells are there, each of 6 volt, they are connected in parallel, then what is the equivalent? Only 6 volt. Okay, great. Now students, see, equivalent EMF EP, now n cells, anyhow what we have seen here, this EP is E, and equivalent resistance, what I told you, Rp equal to R by N. Okay, now the current through the resistance. So again you see here, if I draw here the diagram here, see, this is the situation, no? This is the situation, and here this is the load. This is R, this is EP, and this is the Rp. Okay, so anyhow the current will flow like this, I and I, is it? So what you can tell here, in this situation we can write here I equal to EP means E by capital R plus Rp means what? R by N. Okay, so this is the current in a parallel combination. Okay, see now, if external resistance is much smaller than the total internal resistance of this cell, then the cells should be connected in parallel to get a maximum current. Okay, so what we can write from here, remember that here what will happen that here, see, the capital R is less than R by N, much smaller, previous higher but now smaller. So when R is less than R by N, we can write here R plus R by N. It will approximately become here R by N. Okay, R by N. So in this situation, what will happen that here, this I max is given by, see here please, this is the E means as it is, R plus small r by N will become here small r by N. That means we can write here N into E by R. Okay, so I hope so this thing you have understood very well the important points, is it? Great. Now we are going to see the third kind of situation, the mixed combination. Now important here, if n identical cells each of E comma R are connected in a row and such m rows are connected in parallel, then their equivalent is given by, how many rows are there? M rows are there, and in each and every row how many cells are there? N cells are there. Okay, so just let me draw here, see here, see, I'll just draw here, see, like this I'm drawing here. No, just I'm just trying to show you. Now, so see here please, this is E R, E R, E R, and here how many rows are there? How many cells are there? N cells are there. How many cells, students? N cells. Similarly here also, Similarly here also, see, ER, nah, like this, see, I'm drawing here. How many cells are there? N cells are there. Okay, let me write here. ER, ER, ER. Is it? N cells are there. And like that, students, how many rows are there? See, if I will draw here like this, here, like this, okay, like this here. So how many rows are there? See here, students, M rows are there. How many rows are there? M rows are there. And see here, across terminal A and B, we can connect here the external load. That's not a problem here. Okay, even if you want to connect also here, you can connect. Space is lesser, but okay, we can connect here. This is external load. Okay, so what will happen that here, students, in this situation, equivalent EMF. So see here, please. In first row, E connected N times, that means NE. NE, 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 all are connected in parallel. So equivalent will be how much here? It will be N into E. Okay, whatever EMF in one row, same will be equivalent also. Okay, like I have told you, E and E in a parallel, only E. So similarly, NE, whatever rows are there, equivalent will be NE only. Similarly, equivalent resistance here. So in first row, total resistance NR. In second row, NR. Like that, all are connected in a parallel. So if 2 rows are there, NR by 2, 3 rows are there, NR by 3. Like that, how many rows are there? M rows are there. Okay, so it will come here, students, NR by M. Okay, great. Now see the current. Current through external resistance is given by, so remember that here, this I, no, I will write here, this I is given here, remember that here, we can write here, see, E equivalent by R equivalent plus capital R. Okay, so we can write here, E equivalent means what? NE, R equivalent means NR by M plus capital R. This is going to be the IE. Okay, this is going to be the IE. Now, so here I am writing here, see, this is the thing. I hope so you have understood very well. Okay, total number of cells. Here N cell, again N cell, again N cell, like that M rows are there. That means total number of cells are how many? Mn. Okay, so all these points, students, kindly remember that. Okay, and this mixed combination is very, very important. Okay, now let's see, one more thing is there. See here, see, if external resistance capital R is equal to total internal resistance of the cell, then cells should be connected in mixed combination to get a maximum current. Okay, so remember that here, this capital R should be equal to R equivalent. Okay, that means what we can tell here, this capital R should be equal to NR by M. M rows are there, and in each row N cells are there. Now, this thing you have to remember that. And very, very important, see under the note, mixed combination is used to draw maximum power through external resistance. So in further lectures, when I will teach you maximum power transfer theorem, so there also you will learn capital R should be equal to R equivalent. So mixed combination is just to draw the maximum power from the source. Is it? Great. Now see the students, 4 identical cells of EMF E and internal resistance small r are to be connected in series. Suppose if one of the cells is connected wrongly, then the equivalent EMF and effective internal resistance of the combination how much? So here I have given you the formula, N minus 2M into E. So N how much given here? Total number of cells 4. Okay. M how much given here? How many cells are connected in a wrong polarity? Only one cell. One cell. Okay. So it is given here M is 1. So what we can write here, see here, this E equivalent is given by what? N minus 2M into E, that means 4 minus 2 into 1 means 2 into E. So it will come here what here? 2E. Okay. And if I write here the R equivalent no problem, just NR. So anyhow we can write here 4 cells are there, that means 4R. So 2E comma 4R, where it is that option A is the correct answer. Nothing else. Okay. Nothing else. Very easy. Very easy. Very easy. Okay. Great. Now students, after that, see here this question. This question we are going to see. 2 cells A and B with same EMF of 2 volt each and with internal resistance 3.5 ohm and 0.5 ohm are connected in series with an external resistance of 3 ohm. Find the terminal voltages across the 2 cells. Okay, so first let me draw here the diagram. 2 cells are there. No? So let me draw here. Anyhow, this is one cell, and here also one cell is there, and this is the terminals, and here we will connect here one external resistance. Okay, then only we can solve the question. Now, so first cell is having the 2 volt, anyhow plus minus. This is also 2 volt plus minus, is it? Resistance, how much is given here? RA is 3.5 ohm, this is 3.5 ohm, and second one, how much is this here? Is 0.5 ohm. Okay, and anyhow here they are telling cell A and B na, so here I will take the terminal M and N, that is better, so that I can tell here, see, this is the cell A and this is the cell B. Now then things will be very easy. Okay, and here let's take here some any point. I have taken here O. Okay, so students, anyhow the current will flow in which direction? No? Discharging situation is there, the current will flow like this. How much external load is given here? You can see very well the 3 ohm. 3 ohm. Okay, so in this situation what will happen, that here the current, how much current will flow, you know very well, this 2 volt and 2 volt in supporting polarity, because of this also current this side, because of this also current this side. Okay, so we can write here 2 plus 2. Total resistance, how much here? Add all the resistors, because in all the resistors current is same. Okay, so we can write here, see, 3.5 plus 0.5 plus here 3. Now, so it will become here what? 4. 3.5 plus 0.5. 4 plus 3, that means 4 by 7 ampere. That current is going to flow. Now, what will happen at here? This is the discharging situation. No? So, they are asking the potential difference. So, terminal potential difference across cell A. Okay, so discharging situation V equal to E minus IR. So EA minus IRA, this is your terminal potential difference across A. Now this one here. Across this point here. That I am writing here VA. Even you can write VM minus VO also, no problem. So what is the EA? 2 minus I here, 4 by 7 into RA. How much is given here? 3.5 means how much is there, students, here? 7 by 2. So just simplify this, 7, 7. 2, 2 is 4, so it will become here 2 minus 2, that means it will become here the 0 volt. Okay. Similarly, if we talk about here the second one, na, again V equal to E minus IR. Na. Second, so VB equal to EB minus IRB here. Across point O and N, that means VO minus VN. Okay, so here what will happen at here? 2 minus I, that means 4 by 7. RB, how much is this? 0.5, that means we can write here 1 by 2. Just cancel, so it will become here 2 minus 2 by 7. Correct, na? 2 2 is 4. Then you will simplify this here. 7 2 is 14 minus 2, 12 by 7 volt. Okay, students, I hope so. This question is also you have understood very well. Is it? Easy question. This anyhow, no need. Next one here, please, students. This is the JEE question. Is this JEE question? JEE 2023 question is, see, two cells are connected between points A and B. As shown, cell 1 has EMF of 12 volt and internal resistance of 3 ohm. You can see very well. Cell 2 has EMF 6 volt and internal resistance of how much is given here, students? Let me see here. 3 ohm. Okay, okay. Let's take here 6 ohm. 6 ohm is given here. Okay, this is the 6 ohm. 6 ohm is given. Is it? Now see, an external resistance capital R of 4 ohm is connected across A and B. The current flowing through capital R will be how much here? In an ampere. Okay, so remember that here. First we have to calculate here the equivalent. No? So here, students, the equivalent will be given here like this. This is E equivalent. Here this is R equivalent, and here this external resistance is this. That means 4 ohm is there. Current will flow like this here. Is it? This is plus, this is minus. No? So first let me write here the R equivalent. R equivalent we can calculate very easily. So R1 R2 by R1 plus R2. So we can write here what is here? 6 into 3 by 6 plus 3. So 18 by 9, that means how much here? 2 ohm. Is it? Very easy. After that, here the formula E equivalent by R equivalent is equal to E1 by R1. Here plus, here minus. But here minus, here plus. This is opposing polarity. That means minus E2 by R2. Okay. This is the, I have taken cell 1 and let's take this is the cell 2. Is it? So now, friends, just put the values here. No? So it will become here what? E equivalent by R equivalent, how much here? 2 is equal to E1 by R1. That means 12 by 3. Is it? 12 by 3 minus E2 by R2. That means what we can write here? 6 by 6. Is it? So 12 by 3 means 4. And 6 by 6 means 1. That means we can write here, see, this E equivalent will become here what? 4 minus 1, 3. And 2 will go from this side. So 3 into 2, how much is 6 volt? 6 volt. Okay, see here, this thing and this thing. We are just equating. So E equivalent is coming at what here? The 6 volt. Now all the things are ready. 6 volt is here, 2 ohm is here, 4 ohm is here. Now, can you see very well how we have done this? Is it? Great. So now, students, if I will write here the formula. So it will become here what? See here, this I equal to basic formula E equivalent by R equivalent plus capital R. Now E equivalent how much came? 6 volt. R equivalent 2 and external resistance 4. Is it? So it will become here, see, this 6 by 6 and it will come here water 1 ampere. Very easy. This question came in a JEE exam recent questions. Is it? Great. Now students will see this question. This is also very good question is this. Now so see here. Two cells each of EMF E and internal resistance small r are connected in series and in parallel and are used to find current in an external resistance capital R. If the current in series is equal to that in parallel, the internal resistance of each battery is that they are asking. Okay, so students kindly remember that here. Na? So see here please. So first we can write here the two cells are there. Na? So see here please. For series. So series I will write here the I series is equal to ES by RS plus capital R. Okay. So what will happen at here? See, ES how much here? 2 cells in series means 2E by RS means 2R plus capital R. Okay, great. Similarly, if I write for the parallel, okay, if I will write for the parallel, so here what will become here? See, IP equal to again see EP by RP plus capital R. EP how much here? Whatever number of cells are connected in parallel, it will be E only. Okay, this will become here R by 2 plus capital R. Okay, so let's simplify this somewhat here. Take the LCM, so it will become here R plus 2R by 2. Is it? So it will become here what? 2E by small r plus 2R. Okay, but in the question they told that here both the currents are equal. What they have telling here? Equal. Is it? So kindly see very well. Now we are going to equate both IS equal to IP. Okay, so when I will equate here, see IS is equal to IP. Now, so IS how much is this? We know very well 2E by 2 small r plus capital R. And here how much came here? Now even I forget even 2E by R plus 2R. No? So see 2E by this R plus 2R. Okay. So what will happen that here? See this 2E and this 2E cancel. So we can write here see R plus 2R is equal to 2R plus R. Okay. So what will happen that here when we'll simplify this? See this 2R minus R is equal to 2 small r minus small r. That means what we have got here? Capital R should be equal to small r. External, very very important condition, external load should be equal to small r. Okay, so if you will see here please, then internal resistance of the each battery is, okay. So here what is this? Let's take capital R by 2 and 2 capital R. Now so small r equal to capital R, that means correct option is here, option A is the answer. Option A is the answer. Okay, great. Now students will see here the last question. Last question here please, the question. The M rows each containing N cells in series are joined in parallel. Maximum current is taken from this combination across an external resistance of 3 ohm. If the total number of cells used are 24 and internal resistance of each cell is 0.5 ohm, then we have to see these options and all that. Okay. So first in this question we will note down the data. Okay. So what is given here? External resistance is given here 3 ohm. Okay. Maximum current is taken from 3 ohm here. Okay. Total number of cells are 24. Okay. So it is given here Mn. Total number of cells 24. Next one what is given here? Internal resistance of each cell is 0.5 ohm. Okay. So remember that here in this situation for maximum current, I told you, this concept is used in a maximum power transfer theorem also. So capital R equal to R equivalent, that means NR by M. Okay. So capital R how much is given here? See, capital R is given here 3 is equal to N into small r. You can see 0.5. Okay, by M. So students, we can write here, see this N by M will become here 3 by 0.5, or anyhow it will become here 6. Okay, or we can write here, see N equal to 6M. How much coming? See very well, N equal to 6M. Now, so now I will write here the equations. So see here students, N equal to 6M and Mn equal to 24. So what will happen that here if I put the value here, n is 6m. So this is the 6m is equal to 24. That means here 6m square is equal to 24. Okay. So m square equal to 24. 24 by 6. 24 by 6 means 4. Okay. So what will you m equal to plus minus 2? Minus 2 not possible. So hence m equal to 2. Okay. And if I see from here, okay, so what will be the n? N will be 6m. So 6 into 2 means 6 into 2, how much here? 12. So you can see very well, students, the m is 2 and n is 12. Remember that. So m is 2, n is 12. The correct option is here, option A. Okay, students, so I hope so this combination of the cells video you have understood very well. Keep studying, keep going.